bisectors of triangles, okay, like a perpendicular bisector and an angle bisector. Okay, so we are going to start with perpendicular bisectors. So a perpendicular bisector of a triangle is a line or a ray. Shh, pay attention now, we're taking notes. Taking notes. Okay, it is a line or ray or a segment that is perpendicular, and that's what this symbol means. Perpendicular. Okay, that is perpendicular to a side of the triangle at the midpoint of that side. Okay, so at the middle, that middle point, that's where that perpendicular line goes through. So we are going to draw the perpendicular bisector of it, segment AB, and then mark which segments are congruent. We're going to do that with our protractor, so make sure you have that. All right, so we're going to use our protractor. Okay, have that protractor. Now, a perpendicular bisector is at the middle. Okay, so it's in the middle. So we have to find out how long segment AB is. Okay, to do that, you can use the straight edge part of your protractor. Okay, so we're just going to measure out how long that is, and I would just count each of those little dashes. Okay, so count. We have here 1, 2, 3, 4, 5, 6, 7, 8. About 14. Okay, you need to divide that in half. Okay, so 14 divided by 2 is 7. So now I want to count out those 7 dash marks and make a point. Okay, so I wanted to make that point at that 7th dash mark. Okay, so that's your midpoint. Now we need to make it perpendicular to that segment. So to do that, with your protractor, there's this little open circle in the middle on the bottom. Okay? You need to place the point you just made in that open circle of your protractor. And then see how there's little segments coming off of that? You want to line up your segment AB with those. Okay? Now to make this perpendicular, you see the line going straight up there? Right there? Yeah. You're going to make a dot right above that line. Okay? Because that's where it is 90 degrees on your protractor. Okay, from here you just have to connect those 2 points using the straight edge part of your protractor. Okay, so connect those 2 points. So that line we just made is perpendicular to AB. And the pieces that are congruent are from A to that midpoint there, and the midpoint to B. Okay, so we split it in half. We're going to do it again for that second triangle there. So again, take the straight edge part of your protractor, line it up with segment AB, and you want to count your dashes. Okay, once you find out how many there are, I got about 21. Okay, so you want to divide that by 2. That is 10.5. Okay, so count 10 dashes then. And go a little bit further. Doesn't have to be perfect. And make your point on that segment. Okay, then again, take your protractor with the open circle. Okay, your open circle gets placed on that point you just created. Line up the segments along the bottom there. And then place your next point right above that vertical line to make that 90 degrees. And then you just have to connect your 2 points. Okay, so that is perpendicular. And it did split that segment into 2 equal parts. Okay, we have one more. Again, if you're understanding this, go ahead of me. So place it along segment AB, not along the bottom this time. Okay, along segment AB. Okay, and we'll count those dashes. I got about 17. Okay, divide that by 2, that is 8.5. So I'll make my point at about 8.5. Then place your open circle along that point and line up your segments. Okay, and your second point, you look for that vertical line where your protractor goes to 90 degrees. And we'll make our second point right above that. Okay, and then we just have to connect those 2 points.
Wait, how many points was it?
Just 2.
No, I mean, how high? Was
For
it 7 or what?
to count, it's 8.5. Okay, so again, we label that as perpendicular, and it did split that segment into 2 equal parts. Okay, so notice how it doesn't always connect to that angle. Okay, so with perpendicular bisectors, it does not have to connect to an angle in your triangle. Okay, questions on how to draw those in with your protractor? All right, so our next vocabulary word is called concurrent lines. Okay, so concurrent lines are 3 or more lines that intersect at the same point. Okay, so you have 3 lines that intersect at the same point. So here's 1 line, 2 lines, and 3 lines. They all intersect at that one specific point there. Okay, so we have 3 or more lines that intersect at one specific point. Now, using those 3 lines, that point is called the point of concurrency. Okay, so the point of intersection of those concurrent lines is called the point of concurrency. Okay, point of concurrency. Now, the point of concurrency of perpendicular bisectors in a triangle. Okay, so all 3 of your perpendicular bisectors within a triangle will intersect at one specific point. Okay, so they have a point of concurrency. Okay, that is called the circumcenter of the triangle. Okay, so they do all intersect at one point. Okay, we have a perpendicular bisector theorem that states if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay, that just means equal distance. Okay, they're the same distance from the endpoints. We also have the converse of that. So same thing, but backwards. So if a point is equidistant from the endpoints of a segment, then it is on the perpendicular bisector of that segment. Okay, and I'll explain all this in the triangle below once we draw stuff in. So we have a circumcenter theorem as well. The perpendicular bisectors of a triangle intersect at a point that is equidistant from the vertices. Vertices are your angles of your triangle. Okay, so they're equidistant from the vertices. This point is the center of a circumscribed circle. Okay, that circle is on the outside of your triangle. Okay, so it's on the outside of your triangle. Okay, so in number 9, we are going to find the circumcenter. So that means we need to draw in all 3 perpendicular bisectors. So we are just doing what we did for those 3 triangles above. Okay, you just have to do it to each segment. Okay, so take your protractor. You can start on the bottom, you can start on this side or this side. It doesn't matter. You have to find the perpendicular bisector of all 3 sides. So you're drawing in 3 of them. Okay, so go ahead and start that. So count, find that midpoint, and make your second point.
Like my eyes can't focus on it. How are we going to do this? Center.
Yeah, they shall intersect at one point. So you're just a little bit off. So that's not bad.
Mine does not really exist. And I, it's does not look
We'll do it differently on Monday. All right, did everybody get theirs drawn in? Shh, quiet please. Did everybody get theirs drawn in? So, if you haven't gotten it drawn in, you need to keep going and drawing all of these so you can label it. So your picture, if you are a little bit off, that's fine. But all three of your segments here should intersect in one point. Okay? So that one point is your point of concurrency. Okay? Okay, so that's your point of concurrency. And the point of concurrency for your perpendicular bisectors has a specific name, and that is the circumcenter. So that is where that point is. Now, in the circumcenter theorem, it says something about the vertices. So from that point of intersection, your circumcenter, to the vertice in each angle of your triangle, those segments are all congruent to each other. So if I were to draw in a segment from that angle to that point for all of these, okay, from that point to that angle, from this point to this angle. All of those segments are congruent to each other. Okay, all of those segments are congruent to each other. So I'm going to label these just so we can write that out and you have it on your piece of paper. Okay, you need that to do your assignment. These ones? Showing the congruency. Shh, guys, quiet please. Okay, so we have triangle ABC. Okay, I'm going to label this one point E. So each of these segments are congruent. So I can say segment AE is congruent to segment BE is congruent to segment CE. Okay, so all of those segments from your circumcenter to the vertices of your triangle, they are all the same length. Now you don't have to do this part, so just watch. So your circumcenter is also the center of a circumscribed circle. Okay, that circle is on the outside of your triangle. So it connects that point of concurrency to your vertices. So I'm going to use a compass to draw on this circle because it makes it look nicer. And you'll use a compass on Monday, by the way. So we're going to learn how to do that. So if I were to draw this in, I know it's going to be kind of hard to see. It's moving on me. It's very hard to do on the document camera. There. Okay, do you see that circle? So this circle is why, this circle is why each of these segments are congruent to each other. Because this is the center of the circle, meaning each of these segments to those vertices are radii of that circle. Okay, all of your radii in a circle are congruent. Okay, so that's why this theorem works. It's that from that center point to the vertice. Okay, so that circle should hit each of the vertices of your triangle. Okay? So, shh, guys, please. So that's perpendicular bisectors. Okay, do you have any questions on what that is? Okay, it's at a midpoint and perpendicular. Okay, our second bisector. Shh, guys, quiet please. Okay, our second bisector is called an angle bisector. Okay, so the angle bisector of a triangle is a ray that divides each angle of the triangle into two congruent angles. Okay, congruent angles. So again, we're going to draw these in on our triangle. So you will need your protractor. You need to place your open circle on vertice A. Okay, so your open circle goes on that point A. What don't you have? So you need to line up that bottom segment with the segment attached to point A. Okay, so here I'm going to line it up right there. Then we have to extend our ray here. So if you have another pencil, if you have a piece of paper, whatever, to see where that extends to. Okay, now reading your angle measures, since I'm starting here, that's where I'm starting at 0. So counting up then, okay, we're going to be at about 60. Okay, you count up, you don't count down to create your angle. So this is going to be at about 60. You need to divide that by 2 since it's an angle bisector. That's 30. So see where 30 is right here? Make a dot right by 30. Okay, now when you connect this, you don't have to connect it all the way to that point, just through the other side. Okay, so line up your straight edge. You just have to go through the other side of that triangle. You don't have to connect it to that point. Okay, and then I can label that those two angles are congruent. Okay, we'll do the same thing with the second triangle. So your point A is where you put your open circle. When I line this up, I see that it is 90 degrees because it's along that vertical line there. Okay, so I need to take that 90 and divide it by 2. It is 45. Okay, that's right here. So I can make a dot right next to it. Yes, it's way up here. That's fine. You don't need to connect it to that dot. You just need to line your protractor up from point A to that point and go through to the other side. Okay, and then you can label those two angles as congruent. Okay, go ahead and do the last one. This one you might need a straight edge for. Okay, so line up point A. It's about 70. Okay, so I need it at 35. So 35 is kind of off my paper here. So that's why I said you might need that straight edge to angle 35 in right here. Okay, and then we can just connect those 2 points. And label those congruent. What? Okay, so your angle bisector is a ray. Okay, an angle bisector is a ray. So your endpoint should be at your angle. So it doesn't have to go all the way through the bottom here. Now, just like with perpendicular bisectors, angle bisectors also have a point of concurrency. Okay, so that's where those 3 lines intersect in one specific point. Now, that point of concurrency in your triangle is called the incenter. Okay, that is the incenter. So just like with perpendicular bisectors, we have this theorem here. It is the incenter theorem. So that states the angle bisectors of a triangle intersect at a point that is equidistant from the sides of the triangle. Okay, the incenter is the center of an inscribed circle. Okay, so before we had a circumscribed circle, now we have an inscribed circle. So this one is inside the triangle. Okay, inside the triangle. So just like with perpendicular bisectors, we're going to draw all 3 of these in our triangle here. So protractor, use your angle, put your open circle on that point, figure out where that angle is on your protractor. So for this first one here, I get about 50. So divide it by 2. That's about 25. Okay, so I'd make a point at 25 degrees here. And then again, I can just connect those. Okay, I want to do the same thing on the angle over here. Shh, guys. Okay, so over here, place your open circle, line it up on this side now. Okay, and again, I'm going to look to see where that angle hits. Divide that by 2.
What'd you get?
This is at about 48, so 24. You have to look at the top numbers now because you're going from this side up. So you have to always go from 0 up in numbers. So this isn't quite at this line here. So it's at about 48.
Can I put 50?
You can, but your point isn't going to be in the...
Wait, why did you put all the way over there? You know, outside there.
I went on the outside of it. Okay, so for the last angle, if you need to, turn your paper. Okay, so it's facing, so this line is facing you flat so that you can line your protractor up again. Okay, so I still need to put my open circle on that angle. Line up that bottom segment.
Can I see what your dot is?
What dot? Okay, so this is, I'm going to say at 86, just so it's easier to divide by 2. So 43 is where I'm going to make my point. So 40 is right here. So I have to go 1, 2, 3 more to make my point. Okay, so from your angle, connect to that point. Okay, you guys need to focus and pay attention, please. So here again, all of these should intersect in one point. Okay, again, that is your point of concurrency. And with angle bisectors, that is the incenter.
How did you find that middle one? You just go straight down.
Well, I lined up here. Okay, so you line up your segments. I found where this one hit. It was about 86. So I divided that by 2 to get 43. Put a point at 43.
I just put it right down the middle and then after that straight.
You can't just always put it right down the middle. Okay, so these are angle bisectors. So I bisected this angle, they are congruent. I bisected this angle, so those two are congruent. And this third one, so those are congruent. Okay, so now what the incenter theorem is saying is from this point to the side, okay, from the point to this side and the point to this side, all of those segments are congruent to each other. Okay, so if I label these again, I can state that segment AE is congruent to segment BE and congruent to segment CE. Okay, so each of those segments are congruent to each other using angle bisectors. Okay, the last two problems I have here are using what a perpendicular bisector is or what an angle bisector is. Okay, so I have to find the measure of each of these. So I have to find XY. So I have to find XY. So what I see in my picture here is that both of these angles are congruent to each other. Now from that angle bisector, which is this line right here, to the side of that angle, okay? So from the angle bisector to the side to the side. Each of those have to be congruent. That's what the in-center theorem is saying. Okay? So if you have an angle bisector from that point perpendicular to your sides, those two pieces have to be congruent, meaning this one also has to be 7. Okay, so XY is 7. Okay, number 2, we want to find the measure of angle JKL. So that's this angle right here. Okay, well, what I just said, if these two segments are congruent, okay, that means this is an angle bisector. Okay, so if these two segments are congruent, this is an angle bisector. So since this angle is 37 degrees, the other one is also 37 degrees.